بسم الله الرحمن الرحيم. Assalamu alaikum. Sorry for the delay. Uh, okay. Uh, in the previous session, we talked about hierarchical clustering, and we said that clustering is an important subject in data mining. In clustering, the data that we have, it doesn't have outputs, and we want to learn from a data that doesn't have outputs. Okay, we talked about k-means algorithm. K-means was an algorithm for clustering, and we said that in k-means we have to set the number of clusters, and then k-means it had a loop, and in the loop it was clustering the data based on the distance of the data to the cluster centers, and in each iteration of the loop the cluster centers were updated. This was the k-means algorithm that we talked about, and then we talked about the hierarchical clustering. We said that in this type of clustering we don't need to determine the number of clusters. So this is a difference between hierarchical clustering and k-means. In this type of clustering, the input of the algorithm is a distance matrix, and the output is a tree of clusters. Okay, we said that there are two different approaches for hierarchical clustering: agglomerative and divisive. Agglomerative means that the clusters are built from the leaf nodes to the root node, and divisive means that the clusters are built from the root cluster to the leaf ones. So we talked about the agglomerative clustering in hierarchical clustering, and we said that first we assume that each instance is a cluster. Okay, so for example, if we have 100 data, it means that we have 100 clusters in the first step. Okay, then we get the distance matrix, which is the distance between all of these clusters, and then we enter this loop. In this loop, the first step is that we find two clusters which are nearest to each other, and we combine these two clusters into a new cluster, and then we calculate the distance of this new cluster with the previous clusters. Okay, this is the loop of the hierarchical clustering algorithm. These steps are repeated until we come to one cluster, which is the root cluster. Okay. Okay, I said that I put a video for you in the Darsa site. I put a video for you, and in that video I talked about some of these subjects about hierarchical clustering, and I said that in this type of clustering we are creating a tree of clusters. Okay, and then I talked about the uh, different the different methods for calculating the distance between clusters. Okay, these were the different methods for calculating the distance between the clusters: single link, a complete link, average link, a group average link, a median. Okay, uh, did in the video I didn't talk about any example on this hierarchical clustering? Yes? Did you see the video? I didn't talk about an example of this hierarchical clustering. So yes, I think I didn't talk about it. Okay, so the final, yes, okay. The final subject is an example about this hierarchical clustering. I will talk about this example and then we will go to the next subject. Okay, in this example, we have some data. Okay, let me write the data for you. Okay, assume that we have this data, okay? Assume that we have this data and we want to use hierarchical clustering for clustering this data, okay? So we have a data, this data, it has 5 instances, okay? The data has 5 instances and we want to cluster these instances. Okay, as I said, the first step in hierarchical clustering is the distance matrix. Okay, let me write the distance matrix for you here. Okay, here we have 5 clusters. Okay, because we have 5 data, I said that in the first step we assume that each data is a cluster. Okay, so we have 5 clusters. So we have to find the distance between these 5 clusters. Okay, let me write it for you. Okay. As you see here, okay, we have this matrix and we want to find the distance. Okay, the method the method that we want to use to find the distance between the clusters, the method is called group average link. Group average link. Group average link is the method that we want to use to find the distance between the clusters. Okay, group average link. Okay, in this method, I talked about it in the previous session, in the video. I said that in this method, when we want to calculate the distance between two clusters, we find the average of each cluster, and we get the distance between the averages. Okay, so if we have two clusters, we have to find the average of each of these clusters, and then we calculate the distance of these averages. Okay, in the first step, we said that each of the clusters has only one data, so we have 5 clusters here. Okay, when the cluster has one data, the average of that cluster would be that data. Yes, do you understand this? When the cluster has one data, the average of that cluster, it would be that data, okay? Because we only have one data. Okay, so when we want to find the distance between the clusters, we will use the Manhattan. You remember, I think, the formula. The formula was Manhattan. Let me write it for you. Manhattan distance is equal to okay, this is the Manhattan distance. Okay, this is the Manhattan distance. If we have two data, A and B, and these two data, they are each of them have n dimensions. Each of them has n dimensions: A1, A2, AN, B1, B2, BN. N dimensions. Then the Manhattan distance would be this. Okay, no problem. Okay, okay, Mrs. Astra, you said that x1. Okay, okay. When we want to, okay, when we say the first cluster, okay, this is the first cluster. Okay, for example, the first cluster is x1 is 1, x2 is 2. This is the first cluster. Okay, the average of these cluster, it would be 1, 2, because it's only one data. Okay, so let me write the other distances. Let me write the other distances. Okay, distance between 1 and 2, it would be 1 minus 3 plus 2 minus 3, it would be 3. Distance between 1 and 3, it would be 1 minus 2, 1, 2 minus 1, 1, 2. And 1 and 4, 1 minus 4 is 3, 2 minus 3, and this one is 3. Okay, 2 and 3, it is 3 minus 2 is 1, plus 2 is 3. 2 minus 2 and 4, 3 minus 1, 2, and 2 and 5, it would be 2 plus 2, 4. Okay, and data 3 and 4, 2 plus 1 is 3. I'm using the Manhattan distance, okay? And 2 plus 3 and 5, it would 1 plus 1 plus 4 is 5. And 4 and 5, it is 3 plus 3 is 6. Okay, Mr. Bassett, which one is 8? Which one is 8? Yes, result Manhattan for which data? Because these are the results. These are the results here, okay? As you see, this table is the result. Okay, this table is the result. Manhattan distance. Okay, Manhattan distance. Okay, do you know? Okay, I think you are making a mistake. Okay, let me write an example for you. Let me write an example for you. Okay, for example, data 1. Okay, the first data, it has 2 dimensions. Okay, 1, 2. Okay, the first data. If you want to find the Manhattan distance for the first data, okay, Manhattan data 1 and 2 is equal to, let me write it for you, 1 minus 3 plus 2 minus 3, and this would be 3. Okay, can you see this? Manhattan distance between data 1 and 2. 1 is this data, 2 is this data, okay? Data 1 is 1, 2, data 2 is 3, 3. Okay, you see it here? 1 minus 3 plus 2 minus 3, okay? This is the Manhattan distance between 1 and 2. Okay, you do the same thing between. Okay, so this is the distance matrix. This is the distance matrix. Now we say, we come to the algorithm. The algorithm says find the nearest data. Okay, what is the nearest data in this matrix? What are the nearest data? What are the nearest data in this matrix? Okay, here in this hierarchical clustering, we don't have cluster centers. Okay, we don't have cluster centers. Cluster centers was only in k-means, but here we don't have it. Here, okay, you see that here you see this one, okay? Okay, this is the distance between 1 and 3, so it's 2. And this one, distance between 2 and 4, it's 2. So these two are the nearest clusters, 1 and 3, 2 and 4. Okay? 2 and 3 nearest. No, 2 and okay, 2 and 3, the distance between 2 and 3 is 3. But the distance between 1 and 3 is 2. Okay, this is 1, this is 3, this is the distance. The distance, yes, or 2 and 4. Okay, so we can select 1 and 3 or 2 and 4. Both of them, the distance is 2. So I select 1 and 3. Okay, so let me write it here. 1. Okay, I select 1 and 3. So these two clusters, they are combined together, and we have a new cluster. We name it 6. This is the new cluster. Okay, so this is the new cluster. How can we choose the nearest? Okay, the nearest is the lowest distance. The nearest is the lowest distance. Okay, as you see, the lowest distance is 2. Okay, this is the nearest is the lowest distance. This is the lowest distances. Okay, now so this is, here we combined two clusters, and we have a new cluster number 6. Okay, now what do we have to do in the algorithm? In the algorithm, we have to find the distance of cluster 6 with the other clusters. Okay, so we have to find the distance of cluster 6 with other clusters. What are the other clusters that are left? The clusters that are left are clusters 2, 4, and 5, because cluster 1 and 3, they were combined, and we have cluster 2, 4, and 5 left. Okay, cluster 2, 4, and 5. Okay, so we want to find the distance between cluster 6 and cluster 2. Okay, cluster 6, it has 2 data. Cluster 6, it has 2 data. So, as I said, in the method group average link, we are finding the distance between the averages. The average of cluster 6 is the average of data 1 and 3. Okay, so let's calculate it here. Cluster 6 is equal to, so this is cluster 6. This is the average. This is the average for cluster 6. 1.5, 1.5. Okay? Do you understand this? No, the average is okay. We add. Okay, it is between cluster 1 and 3. The average of 1 and 3. Okay, we add the data in each dimension. We add the data in each dimension and then we divide it by the number of data. Okay, here we have two data. We add them in each dimension and we divide it by the number of data. Okay, so this is the uh, cluster 6. This is cluster 6. Now we want to find the distance of cluster 6 with cluster 2. Okay, cluster 2 is free and free. So the distance between cluster 2 and cluster 6 is free. The distance between cluster 3 and cluster 6 and cluster 4. It is okay. Cluster 4 is this cluster. Okay, this is cluster 4. This is cluster 4. The distance is 2.5 plus 0.5 is 3 again. Okay, and the distance between cluster 6 and cluster 5 is 0.5 plus 3.5, 4. Okay, so these are the distances between cluster 6 with cluster 2, 4, and 5. So you see that these are the distances. We didn't find the distance of cluster 6 with cluster 1 or 3 because they don't exist anymore. Cluster 1 and 3, they don't exist anymore. So we didn't find the distance between cluster 6 and cluster 1 and 3. Okay, no problem. Okay, now we repeat the algorithm. We repeat the loop of the algorithm again, and we want to find the nearest data to um, combine the clusters. Okay, we want to find the nearest clusters. So what are the nearest clusters? What are the nearest clusters? Which two clusters are the nearest? Okay, what are the clusters that are left? Which clusters are left that we want to find the nearest ones? Which clusters are left? Okay, cluster 2, cluster 4, cluster 5, and cluster 6. So we have these 4 clusters left. 2, 4, 5, 6. 2, 4, 5, 6. These are the clusters which are left. Okay, which of these are the nearest? Which of these two clusters are the nearest? 2, 4, 2, 5, 2, 6, 4, 5, 4, 6, 5, 6. Which is the nearest? Okay, you should say two data, two clusters, which are nearest. Which two clusters are the nearest? Okay, 4 and 5, the distance between 4 and 5 is what? Is 6. Okay, but the distance between 2 and 4 is 2. So the nearest clusters are cluster 2 and 4. Okay, so we put it here, cluster 2 and cluster 4. Okay, do you understand? Cluster 2 and 4. So we have a new cluster, cluster 7. Okay, now, so we have a new cluster. Now we have to find the distance of cluster 7 with the other clusters. What are the other clusters? The other clusters are cluster 5 and cluster 6. Okay, we have to find the distance between cluster 7 with cluster 5 and cluster 6. Okay, before that, we find the average of cluster 7, C7. It is equal to 2 and 4. So it's 3 plus 4, 3 plus 2. Okay, it's 3.5 and is 2.5. 3.5, 2.5. Okay, this is the average of cluster 7. Now, the distance of cluster 7 is cluster 5 and 6. With cluster 5, cluster 5 is 1 and 5. So it's 2.5 plus 2.5 is 5. And the distance with cluster 6, cluster 6 is 1.5. 2 plus 1 is 3. Okay, so cluster 7 is nearer to cluster 6. Okay, the distance between cluster 7 and 5 is 5. 7 and 6 is 3. And 5 and 6 is 4. So the nearest is 7 and 6. Okay, the nearest clusters are 7 and 6. So we put a new cluster here, cluster 8. Cluster 8 is like this. Okay, this is cluster 8. And the final step is cluster 5 and cluster 8. This is cluster 9. Okay, this is cluster 9. We don't need to find the distance because there are only two clusters. So this is the result of this hierarchical clustering. Okay. If you have any questions, please ask. Cluster 8 and 9. Okay, cluster 8. Okay, we found the distance between cluster 7 and 6 and 5. Okay, and we see that, okay, cluster 7 and 6, the distance is free. This is the nearest cluster, 7 and 6. So we combine 7 and 6, cluster 8, and then we have two clusters left, 8 and 5. And in this situation, we have to combine them, okay, because we don't have any other option. So we combine cluster 5 and 8 into cluster 9. Okay, because in the cluster 9, we have all of the data. Okay, in cluster 9, we have all of the data, and we don't have any clusters left. So we finish. Okay. Uh, okay, have a 5-minute break, and I will be back after 5 minutes. Thanks. Okay, do you have my voice? Okay, so we have other types of clustering algorithms, density-based clustering, grid-based clustering. These are different. These are other types of clustering algorithms. Uh, Here, I will just have a short description of these two types of clustering. Okay, in the density-based clustering, we are clustering the data based on the density. Whenever the data is dense, dense means the data is crowded. We have many data in a small area. Okay, that would be a cluster. And wherever the data is not dense, those will be the border between the clusters. Okay, this is the general description of a density-based clustering, and we have different algorithms for this type of clustering. For example, DBSCAN and optics. These are two different clusterings of density-based clustering. The second, the other type of clustering is grid-based clustering. In this type of clustering, we have a grid. Okay, we have a grid. Do you know what is a grid? Like this. Okay, this is a grid. For example, okay, this is a grid. Okay, so on the data we have a grid. It means we have some small areas, and the clustering is by combining these small areas into bigger areas, and the clusters are the bigger areas. Okay, so in grid-based clustering, we have a grid on the data, and we are clustering by combining the sections of the grid. Okay, so these are different types of clustering that we have, and the last subject we will talk about in clustering is how to evaluate clustering, the evaluation of clustering. If you remember, we talked about classification. Classification was a type of data mining, and we talked about evaluation in classification. We didn't talk about evaluation, yes? Did I explain to you about accuracy? How do we calculate accuracy? Did I explain this for you? The formula. Did I told you how do I calculate accuracy based on the formula? Did I tell you how do we compute the formula of accuracy? Okay, I think I didn't talk about it for you. Okay, let me give you a little description about evaluation in classification, and then I will talk about evaluation in clustering. Okay, in okay, if we have a data with two classes, if we have a data with two classes, and we name the classes positive and negative, okay? Okay, we have a table here, a matrix, and here we have positive, negative. Positive, negative. Okay, and this is target, and this is prediction. Target is the label of data. Target is the label of data. It could be positive or negative. Prediction is the output of the data mining. Prediction is the output of the data mining. Okay, so we have a target, positive, negative, and we have prediction, positive, negative. As I said, the data has two classes. Okay, one of them is positive, one of them is negative. Okay, if for example we have 100 test data, okay, we have 100 test data, and we want to use this test data to evaluate the classifier. Okay, so we have 100 data for the evaluation of the classifier. The data which are positive, it means the label of the data is positive, and the prediction is positive. Data, the label of the data is positive, and the prediction of our data mining is positive. This is called true positive. If the data is negative and the prediction is positive, this is called false positive. If the data is positive and the prediction is negative, this is called false negative. And if the data is negative and prediction is negative, it's called true negative. True negative. Okay, each of these, true positive, false negative, true negative, each of these are a number. Each of them are a number. For example, true positive is 20. It means that from the data that we used for testing, for example 100 data, from 100 data, 20 is true positive, 30 is false positive. Okay, do you understand this? accuracy, the formula of the accuracy is like this. Accuracy is equal to true positive plus true negative divided by true positive, true negative, false positive, false negative. Okay, this is the formula of accuracy. Accuracy means the number of data which is correctly classified divided by all of the data, the number of all of the data. Okay, no problem with this formula. This is accuracy. Okay, so accuracy is the method we use to evaluate a classifier. If we have a classifier and we want to evaluate that um, classifier, we could use accuracy. But but how do we evaluate the clustering algorithms? We have two different methods to evaluate the clustering. The first method is internal evaluation. In the internal evaluation, we are evaluating the clustering based on the performance of the clustering algorithm. If we have a clustering algorithm, this algorithm, it has a result. The result, what does it say? It says, for example, this data is in cluster 1, this data is in cluster 2, okay? It says which data is in which cluster. That is the result of the clustering. We use that result and we evaluate the clustering algorithm. We have different methods. We have different methods for internal evaluation. Okay, we have different methods for internal evaluation. So internal evaluation of the clustering algorithm means that we are using the result of the clustering to evaluate the clustering algorithm. Here I want to talk about this method, Davis-Baldwin. Davis-Baldwin is a method for internal evaluation of clustering. Okay, evaluation means that we want to say is this clustering good or not? Okay, we want to say, is this clustering that we have done, is it okay? How much is it good? Okay, we want to find this. Okay, if we want to use the Davis-Baldwin method, we have to calculate two different distances. The first distance is the inner cluster distance. Inner cluster distance, it means the distance of each data with the cluster center. if we get the distance of all of the data in a cluster with the cluster center, this is called the inner cluster distance for that cluster. Okay? The second distance is the between cluster distance. Between cluster distance, it means the distance between the cluster centers. Okay, if we have two cluster I and cluster J, here you see that AI minus AJ, the distance between the two cluster centers. This is called between cluster distance. Okay, so inner cluster distance and between cluster distance. Now, if we have these two, inner cluster distance and between cluster distance, the Davis-Baldwin index, it could be calculated using this formula. Okay, first we have to calculate Rij here. This is Rij. Okay, Rij is, this is the formula. Okay, SWI is the inner cluster distance of cluster I. SWJ is the inner cluster distance for cluster J. And SMIJ is the between cluster distance of cluster I and J. Okay, we get this. And finally, Ri for cluster I is the maximum Rij. For each of the clusters, we could get Ri, which is the maximum Rij. Okay? So if we want to evaluate the clustering algorithm, we calculate the inner cluster distance of each cluster, and then we calculate the between cluster distance of all of the clusters. Okay, we do these two for all of the clusters, the inner cluster and the between cluster. And then we could define the Davis-Baldwin index using this formula. Okay. Do you understand this? The second method for the evaluation of clustering, it's called external evaluation. Okay, in the external evaluation, we have to we need the outputs of the data. Okay, so what did I say? I said that if we want to do external evaluation on a clustering algorithm, we need the output of the data. Okay, so this is something that we have. Okay, maybe a question for you. Okay, what does this mean that we have output in clustering? Okay, we don't have output in clustering. Yes, that's right. Uh, in clustering, we don't have outputs, but this is just an experimental uh, evaluation. Okay, so we have a data that it has outputs, and we want to test a clustering algorithm. Okay, do you understand this? So we have a data that it has outputs, and we want to test a clustering algorithm. So this is the second method we could use for testing clustering algorithms. This uh, this rand measure is a method for external evaluation. Rand measure. Okay, you see the formula, true positive, true negative. Okay, it's the same formula as accuracy. I said yes. It's the same formula of accuracy. No difference. Okay, but there is something that is important here. There's something that's important, and that is okay, when we want to calculate the rand measure. Okay, let me. Okay, when we want to calculate the rand measure, okay, we have a data and we have a clustering. Okay, for example, okay, look at this table here. This data, it has x1, x2 is 2-dimension, and this C is the cluster. For example, okay, we have two cluster 1, cluster 2. The first data is in cluster 1, the third data is in cluster 1, and the second one is in cluster 2. Okay, so these are the clusters. These are the clusters of the data, and here we have the target, the outputs of the data. The only point that we have when we want to use this rand measure is that we need to define which cluster is this y equal to 1, which cluster is y equal to 1, which cluster is y equal to 2. Okay, so we have to set this. If we want to use the rand measure, we have to say which cluster is which output. Okay, we have to find this, and when we have done this, we could use the rand measure. Do you understand this? Okay, this is a point that, but we don't need to worry about that. Okay, okay, we could use this rand measure, and there are functions that we could use. Okay, so these are the different methods for evaluating the clustering algorithm. If you have a clustering algorithm, you could use these methods to see how good is the clustering. Okay, you can see how good is the clustering. Okay. If you have any questions about clustering, please ask. Okay, let me talk about your presentation. Okay, did you see the presentation date in Darsa? Okay, these are the presentation dates. Okay, uh, your class, uh, do you have in Saturday? Do you have class in at 10 o'clock in Saturday or 12 o'clock? Okay, so you have class at 10 o'clock. Okay. Uh, okay, so this is not your date. Your date is this one. Okay, the date of the presentation, it will be in the 4 and 11 of day. These two dates are the dates of your presentations. Okay, these two dates are the dates of your presentation. Okay, okay, you are 40 a student. Okay, if you did you see this file? Okay, you are 40 a student. The first 20 students are in the first date and the next 20 are in the second date. Do you understand this? No problem. Okay, so these are the dates and each of you each of you will have about okay, have about 5 minutes 5 minutes for presentation. 5 minutes for presentation. Okay, you can prepare a PowerPoint and then convert it to PDF and okay, use that PDF for your presentation. Okay, so you have 5 minutes. Each of you have 5 minutes for presentation, and you can talk about your article. This is there much time, so you have to talk shortly about your article. What is the idea? What is the contribution? What are the results? Okay, the important things in 5 minutes. Okay. How many slides? It's not important. Just five. If you have 5 minutes, okay. It's usually okay, 1 minute for each slide. Okay, but maybe sometimes you can have more slides or less slides. Okay, the slides should be a summary. Okay, not the whole subject. Just a summary. Yes, you can have five slides, and those slides is a summary of your article, and you should talk about your article in 5 minutes. Okay. Okay. Uh, mm, okay, we have one slide left about the combination of classifiers. I will send a video for that slide. Thank you very much. I hope you have a good time and خدا حافظ. التماس دعا.